So the aim is to look at the orientation of prehistoric structures, and this has been done really in two separate but closely related fields. Landscape archaeology on the one hand. Yes, thank you. Landscape archaeology on the one hand, and this can be whether you're on the GIS science side of landscape archaeology or the humanistic side of landscape archaeology, because Chris Tilley's seminal book also included a study of orientations of some prehistoric structures in Wales. But also in archaeoastronomy, a field that is highly contested within archaeology, but where orientations are used a lot more than they are in landscape archaeology, and that is the field I'm going to be criticizing the most here. But the point is that they both look and collect orientation values to try to look for potential alignments. Structures being aligned to, say, particular hills that might have had meaning in the past, or in the case of archaeoastronomy, particular celestial objects like the setting of the winter solstice sun, the famous alignment at Stonehenge, for instance. So orientations are very important for these two fields. The problem is that the uncertainties in those measurements of orientation have been largely ignored. So I'm going to try to convince you of why that has been happening, or how that has been happening. Let's take this thought experiment. Let's look at a passage grave in Western Iberia, in Portugal. That's an actual plan of a passage grave I surveyed. These are, for those of you who are not prehistorians, these are megalithic sites that have a megalithic chamber and then a corridor or passage, also megalithic. And the entire megalithic skeleton, if you want, is covered in an artificial mound of earth and stone, which is what that is. In Iberia, they tend to be round. In other places, they might be long, like the long arrows in Britain. It's a bit like Newgrange, if you've been to Ireland, just not at that large scale, but Newgrange is an example of a passageway. So here's a plan view, and here's a hypothetical view of what we might see if we were sitting inside the chamber looking at. Now, passage graves are often mentioned as being the simplest case of an orientation that we can get in a prehistoric structure. Stone circles have so many stones that you can have so many directions measured, and therefore many orientations, and therefore many potential alignments. But this type of structure seems to be focusing your attention in one specific direction, the direction of the passage or corridor. So you might think this is very easy to measure. I'm going to try to convince you that it actually isn't. Here's one approach that was taken by Michael Hoskin, an archaeoastronomer who measured over 2,000 of these things in the Western Mediterranean. He would find the center of the corridor and mark it with a surveying rod. He would find the middle of the backstone of the chamber, mark it with a surveying rod. 2 points make a line has a direction. You measure that direction with a compass or a theodolite or a total station. In this case, 90 degrees. And it would point at that location on the horizon if you were sitting inside. Well, that's fine, but I can define orientation in a completely different way. I could have measured the midpoint of the entrance of the corridor and the midpoint of the entrance of the chamber, and measure that direction, and I'd get 93 degrees, 3 degrees off from the previous measurement, and pointing at a completely different part of the horizon. I could also have measured just the side of that wall, or even this one, which isn't particularly straight, but that happens in prehistoric monuments, and get, again, two completely different values, completely different points on the horizon. The question then is, which of these is more closely associated with the orientation as it would have been understood by the people who built this? Or which one of these is closer to the potential alignment that this structure might have or not? And the truth is, without making assumptions, we can't choose one over the other. And now you could say, okay, Fabio, you're just talking about uncertainty. Yes, I am. And the rest of my talk is just about uncertainty. But the problem is that these discussions aren't happening right now. For instance, Michael Hoskin would claim that his measurements had a margin of error of about 2 to 3 degrees. Meaning a measurement of 90 would be somewhere between 88 and 92 and correspond to that bar there. Oops. But as you see when you compare this with what we saw before, that really doesn't capture the total amount of uncertainty that these structures afford. Now, in the UK, we've been trying to shift the focus of archaeoastronomy, bring archaeoastronomy into the fold of archaeology and make it more robust, have a more robust foundation. And that's because most archaeoastronomers are actually astronomers. They have no training in archaeology or the humanities. And some of them don't even have training in statistics. So we've been trying to reframe this as a skyscape archaeology to mirror, obviously, landscape archaeology. And in our manifesto, we have emphasized the importance of methodological and theoretical reflexivity. We need to think about how we are collecting these numbers and how we are approaching them. Which, I know it sounds obvious, but trust me, if you go to our archaeoastronomy conference, you would be, you would see that this isn't actually taken into account. So, some possible ways forward that I have actually done in the past is to take the minimum and the maximum orientations possible. So basically corresponding to that window. But of course, you don't actually know where people would be standing inside the chamber. And if you stand in a different place, just like looking out of a window in your office and you move around, the perspective changes. So you need to take that uncertainty into account. And I've come up with this concept of the maximum window of visibility, which is basically just the minimum and maximum orientations possible given the architecture of the structure. You can measure that in the field in most cases. At the time, I thought this is much more powerful because you can actually say with 100% confidence, and I'm talking about the statistical meaning of confidence, that any potential alignments have to occur inside of this range. Now, whether it's going to happen in the middle of the range, or further to the left or to the right, or matching a peak on the horizon or a notch on the horizon, claiming those things are going to involve assumptions or independent evidence. And in the absence of those things, this is a much better tool. So I actually measured these windows for about 150 of these passageways in Portugal and Galicia. And this is a histogram of the half widths compared with Hoskins' uncertainty value of 2 to 3 degrees. And you can now see more clearly what I mean by the uncertainty having been underestimated or completely ignored. That's the minimum level of uncertainty I found, whereas the mode is actually 19.5 degrees. So there's huge levels of uncertainty in these things, and yet when you look at the numbers in the publications and the inferences that are taken from these numbers, it looks like it's all very certain, but in fact it isn't. And when you use that window approach and you actually look at a clearly identified archaeological cluster of sites, similar sites, same artifactual assemblages, etc., same architecture, you actually start to find patterns where before no patterns were found. That's because when you underestimate uncertainty, you don't see overlaps, but they are actually there. This is all work I've done before. I don't want to bore you with it. I want to try to move it forward by starting with a solid statistical basis. And I think the beginning of this should actually be to rethink the very concept of orientation, or how we approach the concept of orientation. The usual question in orientation studies is, what is the orientation of this structure? Now, that question affords a single answer. It's looking for the orientation, one value. I think it would be much more useful to think of this as, what orientations does this structure afford? Because as we saw before, there is a range of orientations that are possible. So one should be exploring the affordances of a structure with respect to potential alignments, and I'm using the word affordances here in a way that will be familiar for those of you who do GIS. But I don't want to go in that direction today. I want to focus on the method, and the method is statistics, and it's a probabilistic framework for these studies. So let me explain how this works. As an example, I'm using Richard Bradley's survey data from his excavation of the Tom Naviri recumbent stone circle. So instead of using the passage grave I've shown you before, which, as I said, is probably the simplest case, I'm going to show you a much more complicated case. Now, these recumbent stone circles that appear in Aberdeen in Scotland, they were built roughly between 2500 and 2000. We don't have exact dates of these things. They're composed of several stones. There's 2 or 3 missing on this side. But the key feature is this recumbent stone with 2 flankers on the side that are kind of providing this frame. And both archaeologists and archaeoastronomers have claimed that it is kind of framing something. Sometimes it's the landscape, sometimes the skyscape. And these sites have been surveyed by both archaeologists and archaeoastronomers, but they both make the same mistake. They always make their orientation measurements from a putative center of this circle. Now, don't be fooled by the name. These aren't circles. They're not geometrical circles. So there's no one center. And furthermore, the center is not archaeologically defined. There's nothing in the center that would give you a hint that people were actually standing there looking at something. So big question marks there. The other thing is they usually go through the center of their recumbent. But again, that's assuming that symmetry, or the idea of center and middle, was as important for the prehistoric Britons as it is for us today. And that's, in my view, a big ontological assumption. So what do? We take the survey data and we first create an open polygon, in this case it's a line, with the shape of the structure, where we're basically blocking out the areas that, in this case, we're not interested in. We are interested in visibility through the recumbent. So we're leaving the recumbent arrangement open and blocking everything else. Bear with me, this will make sense in a second. Then we can create a closed polygon that corresponds to our uncertainty in where people would have been standing to observe any potential alignments. I could have used the entire circle, but I'm actually using this area that is limited by a curve that is very clear in the archaeological record, much clearer than where the stones are standing. But I could have used any area I wanted. This is just an example. And then, of course, you can take a point inside this area, and you can obtain the range of orientations that don't touch the polygon, the line. Basically, the azimuth range that goes through the recumbent arrangement. You can repeat this for another point, and you can see where I'm going with this. If you take a regular spatial sample of points in this area, and you just repeat this for every single point, you will get a number of azimuth values that you can then use to get a probability distribution by simply using kernel density estimation, which is what I've done here. And you can immediately see that there's a huge range of azimuths possible from within that structure. It makes sense. These things aren't particularly big. And it peaks at a particular value. That's not a normal distribution. But it is a probability distribution, and we can now use it to do much more interesting stuff, in my view. So we could, for instance, compare it with hypotheses for alignments, in this case, celestial alignments. So that's where the December solstice sun would set. You can see that, indeed, you can see it from inside the frame of the recumbent, but it's not particularly close to the peak. I'm not saying that's important. I'm just highlighting or describing what we're seeing there. The summer full moon is Richard Bradley's and Clive Ruggles, the archaeoastronomers, best explanation for these structures, that they were framing the setting summer full moon. But the full moon changes every year. Its rising and setting position changes every year, and it only gets back to the same place 19 years later. So you have this broad range of possible azimuths for the setting summer full moon, but again, far from that peak. However, what is close to that peak, and I found that interesting, is Orion's belt, the belt of Orion's constellation, this massive constellation that is very visible in the night sky, even in the light-polluted skies of London. Today, you can see it. And in fact, this was suggested by a colleague of mine, Liz Henty, who did a more phenomenological approach to this site and identified that actually the image of Orion setting over the recumbents would have been quite spectacular. So maybe this is a suggestion that needs to be considered in more detail. This is certainly what this data seems to suggest. But more importantly, with this probability distribution, we can actually use more robust statistical inference methods. I'm not going to go there because this is still work in progress, but I thought I should at least show you something. So here's a simple likelihood ratio between pairs of these three hypotheses, and you can actually see, as it's obvious to anyone by looking at this, that Orion's belt is the preferred model out of these three, I should say. But I think that the challenge now is to actually employ some more robust model selection approaches, like likelihood-based stuff, or Bayesian, which everyone seems to be a fan of. Here's the flowchart of the method. So we're basically combining doing those shapefiles in GIS with some bespoke R code that does the stuff I explained before. But using the same modules, you can have what I call the top-down approach. So sorry, let's get back here. I've called this the bottom-up approach because you basically start from the survey data and you go up to the alignment. You're climbing Hawk's ladder of inference if you want. But you can also have a top-down approach using the same modules but in a slightly different way, where you can say, okay, I want to test an hypothesis. I want to test whether the December solstice sunset works for this site. So you basically just radiate lines corresponding to that alignment for every point inside the structure and see which ones don't cross the structure. And you can then create a convex hull around that, which will show you the area inside your structure that permits that alignment. And that can lead into interesting things like directed fieldwork or crowd models, which I'm going to mention here. So here's an example. For the same site, you would only be able to see the December solstice sun from this green area, and using Jacob's model for crowd estimation, you could fit about 48 people there if it was a loose crowd, 106 if it was tight crowd, or if it's a mosh pit scenario, I kid you not, that's what Jacob calls it, 192 people. For the summer full moon, because of that sweeping effect of the summer full moon, it's a much larger area, but this is over a period of 20 years. In any one year, it would be a much thinner band. And Orion's belt is more central and actually points straight at the space between stones 8 and 9 that Richard Bradley believes to have been the entrance to the circle, even though I didn't mention that before. The point I'm trying to make is that this allows us to actually start thinking about these claims for alignments in a much more human level and a much more embodied experience type of thing, where we can actually think about how many people would actually be able to see these things. Because sometimes you see these claims for alignments, and then when you look at it, you understand that only one person would be able to see that, and that's not particularly interesting or appealing. Now, this was just to explain the method. We are actually, with Christina, we're applying this to the Middle Neolithic enclosures of Germany, of which she has very good high-quality survey data. Just to give you an example, it's not the highest quality example we have, it's the Gozak Circle, but it's one that has already been described as having alignments to the winter solstice, sunrise and sunset, through these southeast and southwest gates. That's what the reconstruction looks like. When I apply this, one thing that came out, and I think it's potentially interesting, is that it highlighted an area from which you cannot see anything to the outside through these 3 gates. Now, that might have been a built-in feature, or it might just happen. But it was interesting that this has never been observed before. The probability distribution looks like that, 3 peaks. Don't forget that that's 360 north, and 0 is north as well, so it's actually a circular variable. And the claims for December solstice sunrise and sunset, this is where they would occur. You can see that's a nice match, but that's not really a good match. If you do the top-down approach, that's what it looks like. And this also permits you to now look at overlaps between the two. So if 3 to 12 people were standing in that red area, you can actually see the sunrise and sunset without moving. Now, what I'm trying to say is that with this, you can now make crowd model predictions for these alignments that are going to be a lot more refined than the claims that there were tens of thousands of people gathering at these sites to observe these astronomical events. That would simply not work. You can see maximum of 500 people for the December solstice sunset. Yeah. So just to conclude, I think we need to rethink how we do orientation studies, and I think we need to think in terms of affordances and visual perception. And we can do that methodologically through statistics and through probability densities. And this opens up the field to not only much more robust statistics on the one hand, which I haven't gotten there yet, but also thinking about the embodied experience of how these alignments would or would not have worked, which I think will put all these claims and hypotheses in a much more stable and solid ground.